Okay, we continue to one-to-one function, or sometimes we call it as injective. If no value in the range is used more than one value in the domain. Or the other words. For every input, there is a unique output. All the element in the domain have to use, but all the element in codomain need not to be used. Okay. For example, I give you a easy example. Okay, we have elements. Element example, we have 1357. For example, we have here have 1357. And then the example 758911. 75811. Okay, let's say you map like this. Okay, this one is domain. This one is codomain. Okay. Okay. Function injective search active function and bijective function. First, I'm going to explain to you injective function, also known as a one-to-one function. So, because of every input, there is only one output, and so every input is a unique output. That is very important. All the elements in the domain have been used. So, in our domain, in our input values, all of the elements in the domain have to be used in an injective function. For example, we have 1357 yang kat sini, this one, all has been used. Okay, this one is for domain. Okay, but all the element in the codomain do not have to be used. So you can see here the 8 is also not used. This is an injective function because all the input have unique output. 1 goes to 5, 3 goes to 7. Okay, and then 5 goes to 9, and 7 goes to 11. Now, if you look down, also, okay, now I draw you injective function. You can draw for the injective functions. Okay, for example, you have x and y. Okay, this one, y axis, x axis. Okay, so 0, y equal to x power of 2. If you draw uh, a horizontal line across through the graph. Okay, if you draw the horizontal line here across the graph, for injective function, the horizontal line can only cut the graph once. Okay, now the next, okay, only cut the line once. Okay, dia cut dekat sini je sekali. Okay, this one is injective. Okay, is it clear, Faris? Daniel? Spaniza ni senyap je daripada tadi, okey ke? Smart. Eh, line kamu okey tak? Apa dia? Tak. Ha ah. Dia only cut once lah. Okay. This one is injective. Okay, this one I've explained to you. We have domain and codomain. The injective is only map once lah. But sometimes in the element you not use lah. This one is for the range. Let's say for the domain x2, you have range 1, 2, 3, 4, 5. Okay, again, when you map domain to the codomain, okay, because range is a subset of codomain. Okay, okay. Here, 4 is not being used. Okay, okay. Okay, this one-to-one function again. If you look the fx equal to x power 2, this one I explained. The set of integer is it the set of integers one to one for all x, for all y, x power 2 equal to y power 2 is implies x equivalent to y. 1 power of 2 is equivalent to 1. Negative 1 power of 2 also 1, but 1 is not equal to negative 1. The answer is no. Okay, because it cuts more than once. Okay, is it a function fx x plus 1 1 to 1? Okay, we have for all x, for all y. Okay, this also x implies 1. Okay, and then x plus 1 is not the same for y plus 1, only when x is not same with y. Okay, okay, the answer is yes. Okay, for example, this one is injective 1 to 1. Okay. And then we have a surjective function. Surjective function is the every element in codomain is the image at this one element in the domain. So first objective function, every element in codomain is element in the domain. In other words, is codomain is equal to range. Okay. Codomain because this codomain is subset of range, and then codomain is must be the same. For example, for every value in the codomain, there is a value in the domain is the map into it. It map more than once. Okay, look the difference between injector functions. This is a search active function goes to okay. Okay, we have another example here. Okay, let's say you have two here. You have A and B. Okay, we have A, B, C. Okay, for different injector is only one function, and then for the surjective, you can you don't have to have a unique value. Output, okay, you can go from A to B lah. Okay, and then range must be same of codomain. This one is a must lah. Codomain is equal to range lah. Okay, for example, we have map this one have, okay, because it is the same to the range. Okay, J is supposed not to have lah, because it must be same okay, to the range. Okay, like say you have A, B, C, D, and then you have 1, 2, 3, and then codomain is equal to range. Codomain has been used, so that is very important in a surjective function. And the range is equal to the codomain because every single value in the codomain has been used in the range every single input and as used up all of the possible output or all parts of the element in the codomain. Now for surjective functions, you can use the horizontal line test again. Both of these graphs are surjective functions. Okay, for the graph itself, okay, you can have a surjective function. Okay, this one is for the graph. Okay, we have here -2, 1. Okay. Okay, when you do the surjective function, because the horizontal line cuts the graph at least once. Okay, now I know that I said for the injector function it only cut in one, but this cut at least one is also surjective functions. Horizontal line cut at least one, you can see there is cut once, twice, and time in a particular functions. Okay, you can see here when you cut this one. Okay, and then when you cut this one, it cut more than once. Okay, and then we have onto functions. Onto function is a function. Let's say you have fx equal to x power 2 from the set of integers to integers onto. This one is to test. Okay, there exists, then do not exist such x that x power of 2 is equal to -1. For example, -1 is one of the possible value of x. Okay, and then is it onto function? No lah. Okay, is the function fx x plus 1 is onto function? Yes lah. For every y, some x exists that x equal to 1 is a -1 lah. Okay. because it must be in the range, equal to the range. Okay, for example here, not onto functions. Okay, okay, this one is bijective, one to one, but not onto function. This one onto function, but not one to one. Okay, okay, we have a bijective, we have a surjective, and then we have a one to one correspondence. Okay, or both, we have both bijective, injective, and surjective. This function are one to one function, but element in the codomain is used. Okay, let's say you have like this. To explain more on this, we have like this. Okay, we have A and B. A and B. One, two, three, four. One, four, nine, 16. Okay. Uh, okay. Now we want to state whether each the following maps A to B function uh, injective, surjective, or bijective. Okay. If asked to describe a function, let's say if it's bijective, look see again if the both injective and surjective active, and what very important with the search active is equal to the codomain. Now it's a very good example. Okay, we have the mapping. We have the mapping. Let's say F. Let's say we have A and B also. Example one, also A and B. Okay, for the one is mapping A to B. Our one function is two injective, okay, or bijective. Okay, and then give a reason. Okay, so graph number one, the first thing you ask is a function okay. So does the every input and just have one output? Okay, so it there is another way to describe this is A is only one arrow going from each element, and yes, it is okay now. So it is a function, okay, and only one arrow. Okay, this one is a function. Okay, we write it. This one is a function. Okay, we write it a function. Okay, only one arrow from each element. From each element. Okay, in a Okay, two, it is injective. So far, every input there is unique. Unique output, and yes, there is a map only onto one element piece. So yes, it is injective. Okay, this one also we call it as injective. Okay, and the reason is that each element in a map. Okay, because each element A, each element A maps to only one element in B. Okay, so far do you have any question? Boleh, Nabila? Boleh. Jadi kita, I have to explain very calmly and slowly to ensure you get the understanding. Okay, one element in B. Nah. Now the third we ask, is it a surjective? Okay, first surjective. All element of codomain have to be used. Okay, so the range and the codomain and have to be the same. The range of codomain. This is a part A are not the same because the range of uh, where the line connect isn't used. Okay, it's not subjective. It's not on the subjective. Okay, because okay, we have another line here. Okay, this one is not subjective. Number three, this one is not subjective because not all the element. Okay, ada satu elemen yang kat sini yang tak guna lah. It's not subjective. Okay, because the range is not equal to the codomain. Because range is not equal to codomain. Boleh? Amin Newton boleh? Okay, okay. The second, the third one is bijective. Now the third thing we ask is the okay subjective dah tadi. It's not subjective. Okay, it's not bijective. The reason of that because it's not injective and subjective. Remember, be bijective in the function must be injective and subjective. Because it is not injective and objective, subjective now. So moving on to the next. It is bijective, not bijective because it's not injective and okay, it's not bijective. Okay, this one is just the example. And then we have a monotonic function. Monotonic function is either you have strictly increasing or monotonically strictly decreasing. For example, if we map the real numbers, we f is monotonically increasing if x is less than domain, while decreasing is if x is greater than or equal to y. For example, here is fx equal to x plus 1 is increasing. We have fx less than fy, and then fx and minus x plus 1 is decreasing. You can find from bottom to up. Here from bottom, and up, bottom up. This one increase, 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 but this one is decrease. Okay, for another example, we have fx 2x plus 1. We can find out this one is increasing because of the slope. Okay, the slope is negative is decreasing, while whereby the slope positive is increasing. We have 2x plus 1 is increasing. We have negative 3x minus 1 is decreasing. 2x minus 1 is increasing. It's based on the slope. And c is the constant. Okay, this one is another example. Okay, we have decreasing function. Okay, and then we have a increasing function based on the slope. And then we have inverse function. Inverse function is basically be one-to-one correspondent such that function A is equal to B. The inverse function of f is denoted by f negative 1. Is inverse. Okay, so far do you have any question? Ada soalan ke? Okay. Okay, we are going to find the inverse function. For example, we have fx. Okay, for example, we have fx is equal to 2x minus 7. Then the first thing, we replace of x with y. Okay, y. Okay, we have y equal to 2x minus 7. Next step, switch x with y. So x is equal to 2y minus 7. Okay, we have x is equal to 2y minus 7. Then after this step, all you need is to do is isolate the y variable, solve for it, and get by itself on one side of equation. So to do that, let's add 7 to both sides, and we going to have x plus 7 is equal to 2y. Okay, and then we want to isolate x plus 7 equal to 2y, so divide by 2. Okay, also divide by 2 lah. So x plus 7 divided by 2 is equal to y lah. X plus 7 divided by 2 is equal to y. So we can write the final answer as the inverse function is equal to x plus 7 divided by 2. So we can say f reverse of x is equal to x plus 7 is divided by 2. Okay, do you have any question? Is it okay? We replace by the y. Okay, is you want to reverse, you want to inverse. Okay, this one if you have a negative 1 a b, okay, is inverse from b equal to fa function a. Okay, this one is inverse, one to one correspondent. Okay, we reverse the function in a to b lah. Okay, here we replace f a to a. When we reverse is equal to the element is a b. Same goes to here. When we want to inverse the fx is 2x minus 7. We want to replace the x by y. Y is equal to 2x minus 7. X is equal to 2y minus 7. And then x plus 7 is divided by 2. Is also 2y is also divided by 2. And then if you have f uh, reversible is negative 1, x is equal to x plus 7 divided by 2. Okay, a function must be bijective and also it must be one-to-one correspondence. If you have fx and then here you want to have the inverse. Okay, x plus a when you inverse is equal to y minus a. And then if you have a minus x is equal to a minus y. And then if you have mx, if you inverse the function is y divided by m. Boleh